A ferry shuttles people from one side of the river to the other. In still water, the ferry speed is 15 miles per hour and the river flows directly south at 3 miles per hour. Suppose the ferry heads directly west. What is the ferry's speed and direction? So what's going to happen is it's going to try and head directly west, but the river's current is going to push it as well. So let's draw some vectors to represent these. So first of all, the ferry is trying to head directly west. So let's draw a vector for that. And in still water, it moves at 15 miles per hour. So that 15 is the magnitude of that vector. So now we have the river flowing directly south. So the river is going south at 3 miles per hour. So the resultant vector is where we started to where we ended up, and that's the direction that the ferry is going to head. And we want to know its speed and its direction. So we want to find out the length of this vector because that would be its speed, and then we also need to find out an angle. So let's go ahead, and one of the nice things in this one, because we went due west and then this is going south, this is a right triangle. So we don't need to do any law of sines or cosines, we can just do a Pythagorean theorem. And so this is going to be, x is going to be the square root of 3 squared plus 15 squared. And it looks like that rounded to 2 decimal places, 15.3 because it was 297. So we were trying to go to 2 places but had to round that up to a 3. Alright, so the next thing we're ready to do is figure out an angle here. So let's find this angle right here, and looking at our triangle, then we have the tangent of theta is going to be opposite over adjacent, which that reduces to 1/5. So theta is going to be the inverse tangent of 1/5. And so if we put that in the calculator, it looks like we get 11.31 degrees. So theta is 11.31 degrees, and actually it looks like on this one, since this was due west, then from west we need to go around to the south by 11.31 degrees.